Hello guys, so in this video we are going to be solving the the LeetCode problem contains duplicate LeetCode 217. So let's go through the problem real quick. Given an integer array norms, return true if any value appears at least twice in the array, and return false if every element is distinct. So if any value appears twice, at least twice, so it could be more, twice, four times, five times, but if any value, one or two of the values, appear at least twice inside that array, then we need to return true. But if every value is distinct, then we need to return false. Basically, we are checking for duplicate. So if there is a duplicate of any value inside that particular array, we need to return true. So look at the examples here. We have 1, 2, 3, and 1. You notice that 1 is a duplicate of 1 here, so we return true. And then you have 1, 2, 3, 4. We are going to return false because every value inside here is unique, or there is no duplicate. And let's go down here. You see we have some constraints here. The first constraint says 1 is less than or equal to norms.length is less than or equal to 10 to the power 5. So this simply means that the length of the array norms is always, or the length of our array is always going to be greater than or equal to 1. So what does that mean? It simply means that our array is never going to be an empty array. So the length of the array is always going to be greater than 1, and it's never going to be 0. So our array is always going to be, our array is never going to be an empty array. And there's another constraint here that says 10 to the power 9 is less than or equal to norms I less than or equal to 10 to the power, sorry, negative 10 to the power 9, sorry, is less than or equal to norms I is less than or equal to 10 to the power 9. And what this means is that the values inside our array are always going to be positive and negative integers, from negative 10 to the power 9 to 10 to the power 9. So at a certain point we are sure that we have positive and negative integers. Okay, so one very straightforward way in which we can do this is simply by brute forcing, right? So I can, let's say if we have our array like this, 1, 2, 3, and 1. Let's take for example the first example, the DJ. We can brute force through this and check each and every item for duplicate. So I can go through 1, and I'm going to go through 1 and check with 2. Is 1 a duplicate of 2? No. And check, is 1 a duplicate of 3? No. Is 1 equal to 3? No. Is 1 equal to 1? Yes. Then it returns true. If not, I keep on doing the same thing for each and every item value inside this array. I will go and check with 2. Is 2 equal to 3? Is 2 equal to 1? You notice that I am not going backwards, so I'm not checking backwards again from 2, because I already did that with, so I just keep checking for the rest of the values at the right of the array, on the right side of the array. So what you notice, to check for duplicate on 1, also to check if 1 is a duplicate with all the other elements, all the other values inside this array, just for one value inside the array, the time complexity for that is O of n. And we are doing this for all elements inside the array, or for all values inside the array. So you notice that at the end of the day, the time complexity becomes O of n squared, which is not good. So we can try and see if we can have a better solution for this. But one thing we have to notice that the memory here is of 1, because we're not using any extra space. So the space complexity is always constant space of 1. And one thing I notice is we can trade off some memory for this particular question and then optimize for speed. So we can trade off some memory and then see how. So let's look at a couple of better ways in which you can do this. If you have our array like this, okay, and let's say we can trade off, initially we had time complexity of O of n squared, and memory of 1. So we want to see how we can optimize this, right? We want to see how we can make this better. So just like I said, we can create a hash map we can create a hash map here or a hash set. Basically, I prefer a hash set, which is basically just a set. So what is set is better simply because it takes in just unique values of an unique values. All right, so if you have an array, you can have duplicate values. Maybe one can appear 3 times or two can appear 4 times, but a set simply takes in unique values, and it is very good for us because we are checking for duplicates. Okay, we can use this to check if an item is coming in twice or an item already exists inside our set. So we can use a set. So what this is, set is just another form of data structures, and we can you see if we have our set, a set like a set, if we are passing in maybe this array to a set, this becomes 1 2 3, and one is not going to go in because one is already here and it's going to be a duplicate. So set takes in just unique values. Okay, so this is also a very important part about sets, a very important trick about sets, which help us solve some types of problems in programming. So what we can do, so basically what I'm going to do is I'm going to create a set. Let's say I have an empty set here like this. I'm going to create an empty set, and I'm going to check, I'm going to go through this array. I'm going to check for the presence of each value inside this array, inside this set. If it is inside a set, then I'm going to return true, which means that it's already existing and that's a duplicate. But if it's not inside the set, then I'm simply going to push it inside that set. So I'm going to start here, say 1. I'm going to take 1 and check, is 1 inside here, is not there, then I'm going to put it. So I'll have 1 here. I'm going to do the same thing with 2. Is 2 inside that set? No, it's not there. I'm going to put it. I'll have 2 there. I'm going to do the next thing with 3. Is 3 inside the set? No. Then I'm going to put it here. I have 3. And I'm going to check with 1. Is 1 there? Yes. Then I'm going to go out and return 2. But we are going to do this continuously for the length of the set, for the length of the array, sorry. And we notice that we don't have to go through the entire array. We don't have to go through the entire array. At any point we get a duplicate, we simply have to return true. And one thing we have to know here, is that we are going to be creating a data structure, and the length of this set is going to be dependent on the length of the input array and also the position of the duplicates. So we'll this is simply going to be O of n. So the memory here will probably be O of n. The memory, the space complexity will be O of n. And you notice that we are going through this array just once. So we are going through this array simply just once. So we are looping through this array once, and so we are going to have a time complexity of O of n. We are going to have a time complexity of O of n, which is quite a better solution compared to what we had here, which is O of n squared. So it's always better to have one loop than to have nested loops, or it's always also better to have maybe 3 or 4 loops than to have nested loops. So yeah, I think that's a way we can optimize this and have better speed. Also, one thing I also noticed, rather than just we can also have a better speed rather than just creating a set and passing these values. We can convert the array into a set and check if they have the same length. So if I have to convert this array to this set, you notice that the length of this array is more than the length of this set because there is a duplicate. Because when you pass in this array to this set, it takes in all the values except the duplicate. And you notice at the end of the day, the length of the set is always going to be smaller than the length of the array. So we can do this. We can simply just say, okay, we pass in the array to the set, and if at the end of the day the length of the array is not equal to the length of the set, then there was a duplicate and we return true. If they are the same, then all values were unique and we return false. So that's another solution we can provide. And this is, I think this is one of the best ways we can do this. Just hit me up if you have a better solution or a better idea. So let's go ahead and implement this in code. So we are going to write the code for this. Yeah, so I can start by creating a set. I think that is nums, not num. And so I'm going to check if no, let me create an empty set rather. So I'm going to check for the number of for num in nums. I'm going to loop through nums ones and I'm going to check if a number is inside my set that I just created up here on my nums, my new set. If it is inside there, I'm going to return true. Else, if it is not inside there, then I'm going to put it inside there. So I'm going to say new nums dot add num. And if at the end of the day, all of this, nothing was returned true, then we know that all the numbers, all the values inside the array was pushed to the set and there was no duplicate, then we simply have to return false. Okay, so let's see, let's submit this. I'm going to submit this. So wow, that's great. It's faster than 70% of solutions. So we could do this, right? Just like I said, we could check for the length. We could include that and check for the length of the set and the array. So if I create by passing the array to the set to create maybe a set from the array, and then I check if the lengths are the same. So I'm going to check if the length of the numbers is the same as the length of the set that I created, or if they are not. So if they are not the same, then I want to return true. Otherwise, they are probably the same and there was no duplicate, then I have to return false. Okay, let's submit this and check. Yeah, so that's faster than 63% of the solution. Okay, so yeah, well guys, thank you very much for following this video. Welcome to the end of this video solution. Subscribe to the channel, like, share.